Hey everyone, happy Thursday, and I hope your midterm 3 went well. I know Sherry would love to have your feedback, so my first point today is if you don't feel comfortable sending directly your feedback to her, go ahead and send that to me so that I can pass that along to her, because I think she really wants this final to go as smooth as possible for you guys. I'm guessing it'll run in a similar format to midterm 3, but I've been talking with her recently and making sure all the directions are clear so that you guys don't run into any issues while you are taking your exams or quizzes. I hope you are all staying healthy and safe and are staying inside with this crappy weather we're having. But as you probably saw in her notes that she posted today, 4.6 is what we're moving on to, and that is the last section for the semester. Not to be confused, it still is very important, even though it is covered last, and I encourage you to take it seriously, because this is kind of the real life connections and applications to what you could potentially work with in the future, depending on the field you go into. That being said, I want to jump down that and say that these questions are pretty important, because this is going to be on the final, and there won't be any exam over it first, but you will have a quiz number 9, maybe 10. I think it's only number 9. That will be Monday, and that will be only over 4.6. And the quiz is Wednesday. Sorry about that. Your homework's due Monday. Homework 13 is your last homework, and that's due Monday, and that is the only section that your homework is over again. So 4.6 is all you've got left really to be working on, and we're in the home stretch. This is the last new content today, and then the next 2 weeks, I kind of have a plan for how I'm going to spread out what you've learned throughout the whole semester and briefly touch on all of that again before giving you a practice midterm. I have not made any decisions on that yet, but it will be coming at the end of the next 2 weeks. And you're pretty lucky, because she's not extending the semester into adding new content at all. It's really just going to be review for the next 2 weeks. So that gives us more time to get ready for that final. And if you did pretty good on midterm 3, you can be confident in the format that the final will be in. So let's get started. Let's see. All of the story problems that she covers in 4.6 and then I share with you today are possible exam questions. You have to keep in mind that at this point here, that this is the last fourth. One section is considered the last fourth of the class. So around a fourth of your final exam will be over 4.6, which typically is 2 to 3. I would say 3 is probably the sweet spot of questions that come from 4.6 in the final. So let's go over some practice problems that I sent you, because she didn't really send you anything new today. This is really just being able to read and figure out what the questions are really asking you. So if you have not done the practice problems that I sent you, either get those out now or pause the video and do the problems, because I want you to get some practice before you jump right into this. So, first one I want to go over here is I will read the full problem for you. I kind of just made a note of it here. 200-gram sample of californium-250 will decay to 130 grams in 8.1 years. First step is going to be find an equation that will model how much of the material will remain after t years, and it wants you to round to 5 decimal places. So our first step here is going to be setting this up, because you have to solve for r to get that new equation. So even though it doesn't tell you need to solve for r, you need to realize, what do you need? In order to get this new equation. And here we find out that we need r. So you need to use what you know, set up the equation. And then I've started by taking the natural log. And when I take the natural log of e, I can just say this. So I just divide all of that by 8.1 in my calculator to get r is equal to negative 0.05318. Why is this a negative sign? The K. That's your key here. All right, so now with our r, we can plug it in to this equation. Our amount is what we want to find. So we want to make that our unknown variable as well as our t. C of A equals 200 e to negative 0.05318 t. Word of advice, too, would be careful making your t's, although now you're taking online exams, so you shouldn't have too many issues with handwriting being a problem. The next part of the question says to use your answer from part A to determine how long it will take until only 15% of the sample remains, round to the nearest tenth of a year. So let's look at that. And we want 15% of 200 to be this amount here. So 200 times 0.15 to get our 15% of 200. This is what we're solving for as our t. So now these cancel. And you can say natural log of 0.15 is equal to the natural log of e to the negative 0.5318 t. Still solving for t. So then you get the natural log of 0.15 is equal to negative 0.05318 t. And you can do that division to get t is equal to 35.7 years. Now I want you to determine the half-life. Don't be thrown off by this. This is not a new question. Still doing the same thing, but how are you going to determine the half-life? Well, you have 200 milligrams, and you want to know the half-life, so you want to know when A is equal to 100. So you're still doing the same thing as you did above. It's just not telling you the percentage you want. You're still solving for t, because that amount of time will be the half-life that it required to get the half the amount that you started with. So we can do this. And then you get the natural log of 1/2 is equal to the natural log of e to the negative 0.5318t. Get rid of that. And then you have the natural log of 1/2 divided by negative 0.0318 equal to t, which t should equal 13 years. All right, next, going to move on to, let's look at my notes. The next problem I have for you, I'm going to read it to you quickly. A 45 milligram sample of cesium-137 decays to 22 milligrams in 29.23 years. Find a function of the form qt of q sub e negative kt, which models the amount kt of this qt, I was saying kt, of this sample of cesium-137 left after t years. Round k to 4 decimal points. I don't know about you, but this can be a little overwhelming when it's giving you all this verbiage. Like, what does this mean? What does this want me to do? And that's half the battle, is knowing what the question actually wants you to do, right? So here you can see I've kind of circled some of the key information, in my opinion. I want to know how I can go from having 45 milligrams to only having 22 milligrams in 29.23 years. So here I'm missing this rate of k. So we need to find that equation. So I'm going to advise you and challenge you, if you haven't done the worksheet yet, and then the ones that I don't go over in this presentation, to go back and circle or highlight, find the method that works for you, that points to you what the question is really asking. And here I have, what does the negative sign mean? Negative equals decay. No sign or positive equals growth. That is important, people. All right, so we have to find that equation again so that we can have t as our variable, and we already have t. So we need to find k in order to be able to go to t. So we've got 22 milligrams. You started with 45. And it told you to use this equation. Got to solve for that, and t is equal to 29.23. Okay. Now, let's divide over the 45 to get 22 over 45 equals e negative k 29.23. Now you can take the natural log of both sides. And you can solve. Just like everything else we've been doing, this is the same thing now. So you can take the natural log divided by, I'm going to recommend you take the divide by that negative so that you can get the positive t you want. And k is going to equal 0.0245 years. So now you have your new t. So you can write out your new equation. Your k. This is equal to your k. Don't get confused like me. Okay, so you have qt equals 45 e to the negative 0.0245 t, using what you did over here.